Now we are ready to look at a couple of reactions. We're going to look at two reactions that alcohols can do. And the first reaction that we're going to look at is called dehydration. When we were looking at reactions in the videos that I put up for you to look at yesterday, the way that I structured that was that I would show you a very generic molecule, and then I would show you an actual molecule, and then we do a couple of examples. And we're going to do it the same way this time. So to do a dehydration reaction, you have to have two carbons at least, and they have to be single bonded to each other. One carbon has to have a hydrogen on it, and the other carbon has to be an alcohol. It has to have an OH on it, and that's required. And then as far as what else is present, it doesn't matter. So it could be anything else out here, but you have to have the two carbons side by side, one with an H, one with an OH. This reaction uses acid as a catalyst. And so maybe you'll see H2SO4 written underneath the arrow. H2SO4 is that acid that's used to catalyze this reaction most commonly, but I'm going to list a few other things that you might see. And so in this reaction, what happens is we keep the carbons and we keep the four random things that are attached to them. The carbon-carbon single bond becomes a double bond, and we make a molecule of water. And the molecule of water comes from the loss of the H and the OH from the initial starting material. So before we look at some more examples, let's see at how else you might see this phrased. So instead of saying H2SO4, you might see H2SO4 catalyst. That's just specifically saying that the sulfuric acid is acting as a catalyst. You might also see H+, which is an abbreviation for H2SO4. And you might see heat included with any of these chemicals, H+ or H2SO4. So you might see heat thrown in there also as well. Could be any one of these things. Let's look at an example. And let's try to mix up the way that this is presented. So I'm going to do H+ on top, and I'm going to write heat on bottom, because you've got to be like a ninja. You've got to be able to see these reactions presented to you in a variety of different ways. So when I'm looking at a dehydration reaction, what I want to do is identify my business carbons. So I want to identify first, the one that's easiest to spot, identify the carbon that is holding that OH group. That's the first carbon that I'm going to identify. And so that would be like this carbon right here that's holding the OH group. And the next thing that I want to identify is that carbon's neighbor. That carbon's neighbor is this guy right here in blue. I'm going to draw it in blue up here as well. So I'm finding its neighbor. And I want to make sure, it's not necessary to draw it, but I want to make sure that there's at least one hydrogen on the blue carbon, because that's a requirement. One of those hydrogens has to go away in order for this reaction to work. So once I have identified my red carbon and my blue carbon and my OH and my H that's going to disappear, I am going to redraw my molecule. I'm going to not forget about my red carbon and my blue carbon. And that hydrogen that did not get highlighted green, it's still there. And hey, while we're at it, you know, there's a couple of hydrogens up here on this red carbon. Maybe we'll draw them in too. A couple hydrogens up here. And then I want to put a double bond in between the red and the blue carbon because that's where it goes, and show that I have made water, which I can write as HOH or H2O, coming from the loss of the hydrogen off the blue carbon and the OH off of the red carbon. Let's try another example. So for this one, let's write H2SO4 catalyst. So first thing that I'm going to do is I'm going to start by focusing on the OH. And I'm going to find its carbon, and I'm going to call that carbon red. That a red carbon right there. And then I'm going to find a neighbor to that red carbon. I want another carbon that is its neighbor. And this particular red carbon has two neighbors. It has one to the left, and then it has one down below. And I can choose either one of them. It's not going to matter which one I choose. So I'll choose the one down below right here. So I'm going to identify that guy right there. And I want to make sure that that blue carbon has at least one hydrogen on it. The line structure shows me that that guy has two hydrogens on it. So that's cool. And I know that one of those hydrogens is going to be removed in the course of this reaction. And since I'm drawing hydrogens in, I don't want to leave out the red carbon. I'll draw its hydrogen as well. So now I'm going to draw the product of the molecule, or product of the reaction. I am going to, just to keep things clear, I'm going to highlight my red carbon, I'm going to highlight my blue carbon, and I'm going to draw in everything that's not highlighted in green, because the green stuff is the stuff that we removed, HOH or H2O. And last but not least, a double bond in between the red and the blue carbons. And there you go.